My name is David Swed from RC Robot, and today I'm going to be walking you through how you can connect the L298N motor driver to an ESP32. Now, the motor driver can control up to 2 motors, but in this tutorial I'm just going to be walking you through how to connect up one. The connections for the second motor are pretty much the same, but just with different pins. The power input from the L298N motor driver can be from 5 to 35 volts if you have the jumper installed. Now, if you don't have the jumper installed, you can go from 3 to all the way up to 46 volts, but you need to supply an additional 5 volts to actually turn on the device. The TT motors that I'm going to be using in this tutorial can take anywhere from 3 to 12 volts. For this, I'm just going to be using 6 volts. Now, the power supply should be connected to VCC and ground on the motor driver. Sometimes VCC is labeled as plus 12 volts. For the ESP32 connections, we're going to be connecting pin 14 to enable 1 on the driver, and then pin 26 to enable 2 on the driver, and pin 27 to enable 1 on the driver. Now, the enable pin on the motor driver controls whether or not the motor is actually being driven. The other 2 pin connections control which direction it goes. If one connection is high and the other is low, then it'll go one direction. If they're flipped, then it's going to go the opposite direction. Both of those 2 inputs need to be connected in order to work. Don't forget to connect the ground pin on the ESP32 to the ground connection on the motor driver. Now, if you don't want to run the ESP32 off of your USB connection, connect the VN pin to the 5 volt output on the motor driver. Now, I'll start walking you through to the code. Alright, at the start here, I am labeling all of the motor pins that we're going to be using. So motor pin 1 is 27, motor pin 1, pin 2 is 26, and the enable pin is connected to pin 14 on the ESP32. Here I'm setting up some variables to control the PWM output of going to the enable signal. So the frequency is being set to 30,000 Hertz. The channel inside the ESP32 we're using is going to be channel 0, and the resolution is... Now, the duty cycle is what's going to be actually controlling the speed of the motor. The range that we are able to use with this setup is 170 to 255, 255 being the fastest possible speed. Anything below 170 I found is a little bit unreliable with this setup, but 170 does give a nice low motor speed with this TT motor. If you have a different setup, you might have to experiment on what your actual range is. Now, the actual setup, I'm setting all of our pins to be outputs, and then I'm setting up our PWM output that's going to be going on the enable pin. So I'm setting the channel, frequency, and resolution, and then I'm attaching it to our enable pin, and then I'm actually writing the output to the PWM channel. So I'm using the duty cycle variable, and it's being written to this channel, and that channel is mapped to the enable pin. Now, inside the loop is where we're actually going to be moving the motor. So to set it to go forward, I'm setting pin 1 to be high and pin 2 to be low. Then I'm waiting 1,000 milliseconds. And then to get it to move the opposite direction, I'm reversing which way the pins are going. So pin 1 is going low, pin 2 is going high, and another delay. Now, to get it to actually change speeds, so before we were just going with our initial speed, which was 170, our slowest speed. Here, I'm actually going to be increasing it as we go. So starting at 170, I'm going to increase it all the way up to 255 with a 50 millisecond delay in between. So we're telling it to go forward, and then slowly increasing the speed. And then after that, I'm setting the speed back to 170 and writing that out to the PWM channel, and then I'll loop back around and repeat.